This is Advanced Math 12.4 homework questions. That's Advanced Math, Unit 12, Lesson 4. These are the problems here that I'm going to go over, starting with number 7. Off the worksheet, it's log base 2 of x minus 3 minus not equals minus log base 2 of 2x plus 1 equals negative log base 2 of 4. Okay, and you're asked to solve. So what I'm going to do is I'm going to bring this negative coefficient up as an exponent, and everything else I'm going to leave the same. Log base 2 of x minus 3 minus log base 2 of 2x plus 1 equals log base 2 of 4 to the negative 1. Now, because of this minus sign, I can condense these two separate logs into one log as a fraction because they have the same base, equals log base 2 of 1/4 because 4 to the negative 1 is 1/4. Okay, so now they have the same log, they both have the same base, and there's exactly 1 on each side. I'm going to drop the logs. X minus 3 over 2x plus 1 equals 1/4, and I'm going to cross multiply. 4 times x minus 3 is 4x minus 12 equals 2x plus 1. Subtract your x, add your 12, you get 2x equals 13, x equals 13 over 2. Now, just remember that you cannot take the log of a negative number. 13 over 2 is what, 6.5? 6.5 minus 3 is positive, so log base 2 of a positive is going to work. 2 times 6.5 plus 1 is still going to be positive, so log base 2 of a positive number is going to work. There's no x over here to check, so 13 over 2 is an okay answer. Which means you do have to check your work, guys. That's what I'm getting at here. You do have to check, not because you may have made a mistake, but because there's a possibility of extraneous solutions. Okay, number 12. Log base 2 of 8 raised to the x over log base 2 of 1/4 equals 1/2. All right, separate fractions. Look at this one here and this one here. This is log of a fraction. This is two separate logs in a fraction. Log of a fraction with two separate logs. Two different types of fraction problems. So I'm not going to condense or expand or do anything here, but I am going to multiply both sides by the denominator. The reason I'm going to do that is so I don't have the fraction. So I'm going to multiply by log base 2 of 1/4, log base 2 of 1/4, so that they cancel out, leaving behind log base 2 of 8 raised to the x equals 1/2 log base 2 of 1/4. I'm going to bring that 1/2 power up. Log base 2 of 8 raised to the x equals log base 2 of 1/4 raised to the 1/2. Because there's exactly one log on each side, and they both have the same base, I'm going to drop them. 8 to the x equals 1/4. The square root of 1/4 is 1/2. I'm going to get them to the same base. 2 to the 3rd raised to the x equals 2 to the negative 1. 2 to the negative 1 is 1/2. 2 cubed is 8, so I didn't change its value, just the way it looks. 2 to the 3x because I multiply exponents. 3x equals negative 1. I dropped the base because they're exactly the same and there's exactly 1 on each side. X equals negative 1/3. Okay, so remember what I said earlier about checking. Some are easy to check, like you can just kind of check it in your head and you know it works or doesn't work. Some are a little bit harder. So I'm going to check that x equals negative 1/3. That does not give me log of a negative. And I only have to plug it in wherever there is an x. So that right there is the only place there's an x in this original problem. There's no x over here, there's no x there. So I just want to make sure that this piece here does not come out to be a negative, because I cannot take log of a negative number. Log base 2 of 8 to the negative 1/3 becomes 1/8 to the 1/3, which is log base 2. The cube root of 1/8 is 1/2. So I end up with a positive number, so it checks, it is good. If this had been log base 2 of negative 1/2, then I would have to say no solution. Okay, that is it for that number. I am moving on to number 14. And number 14 reads log base 9 of the square root of 10x plus 5 minus 1/2 equals log base 9 of the square root of x plus 1. Now, I'm going to do it the way I did it in notes. Just a really quick side note, some kids would write this 1/2 as 1/2 log base 9 of 9, because log base 9 of 9 is equivalent to 1. 1/2 times 1 is simply 1/2. That's not the way I showed it in notes. I'm just showing you there's other ways to do it. I'm going to do it the way I did in notes. Log base 9 of the square root of 10x plus 5. I'm going to move this log over. Subtract log base 9 of the square root of x plus 1 equals, I'm going to move that negative 1/2 over to positive 1/2. Now, again, if you didn't want to do it this way, you would change 1/2 to 1/2 log base 9 of 9, condense, drop logs, and solve. Okay, since there's a minus, I'm going to condense it to log base 9 of square root 10x plus 5 over square root of x plus 1 equals 1/2. Since there's not a log on each side, I cannot drop the log. I'm going to do the wraparound. 9 raised to the 1/2 power equals that big base, or big parentheses, not base. So 9 raised to the 1/2 power equals the square root of 10x plus 5 over the square root of x plus 1. All right, now up to you. I'm just going to take the square root of 9 is 3. You technically don't have to, and I'll show you why in just a little bit. I am going to square both sides because you undo a square root by squaring. Square roots and squares are inverse operations. They undo each other. 3 squared is 9. Undo the top radical and the bottom radical. 10x plus 5 over x plus 1. Now, the reason I said earlier you don't have to take the square root, because if you had squared right here, squared would give you this. Squaring the 9 to the 1/2 would undo the 1/2, leaving you with 9. Your choice on how you do it. All right, I am going to multiply both sides by x plus 1. Distribute the 9. 9x plus 9 equals 10x plus 5. Subtract the 9x, subtract the 5, x equals 4. All right, we're going to check. 4 plus 1 is positive. The square root of a positive is positive. We're good. 10 times 4 is 40. Plus 5 is a positive. Square root of a positive is a positive. There's no x here. I don't have to check it. So we're good. That is a solution. Okay, next one I am doing is number 17, which reads log base 5 of 1 over x minus 1 over x plus 1, close parentheses, equals negative log base 5 of 30. Okay, in order to drop the log, I am going to bring that over as a power. And I'm going to have log base 5 of 30 to the negative 1 equals. Now, you can clear it now, not clear it, I'm sorry, condense it now. I'm just going to leave it. When I did this one with the Zoom video, I did it a little differently. So those of you that watched, that were there for the Zoom video, you now have 2 ways of doing it. Okay, in the video I combined these first This one I'm not going to. I have exactly one log on each side. They both have the same base. I'm going to drop it. 1 over x minus 1 over x plus 1 equals 1 over 30. Okay. And I am going to clear my fractional equation, and we did it back in unit 1 or unit 2 where we cleared fractional equations. X cannot equal 0 or negative 1 was a restriction, and we multiply everything by 30 times x plus 1, 30 times x plus 1, and 30 times x plus 1. Okay, first one, the x's reduce, leaving behind 30 times x plus 1 minus x plus 1 is gone, leaving behind 30x, equals 30 is gone, leaving behind x and x plus 1. 30x plus 30 minus 30x equals x squared plus x. If you don't like this way, then watch the Zoom video, and I do it a different way there. Okay, like terms, gone. 30 equals x squared plus x, subtract 30 over. 0 equals x squared plus x minus 30. 0 equals double bubble x minus 5, x plus 6, x equals 5 comma negative 6. Now, kids will say, oh, negative, you can't take the log of a negative, so the negative's not going to work. That's not always the case. Be careful. Sometimes the positives don't work and the negatives do. Sometimes neither of them work. Sometimes they both work. So don't say it works or doesn't work based on positive or negative here. You do have to check them. You can't take the log of a negative, but you won't know until you check. Okay, so the only place I have x's is right here. There's no x over there, so I don't have to check there. Okay, so I'm going to have log base 5 of 1 over 5, that's where the x used to be, minus 1 over blank plus 1, and that's another 5 plus 1. Now, this one's not as easy to do in your head, so you're going to have 1/5 minus 1 over 6. Common denominator, you can do that on your own. You end up with 1 over 30, which is a positive number. That's what we're checking for, so the 5 does indeed work. All right, now let's check x equals negative 6. Don't assume it's not going to work because it's negative. You do have to check it. Okay, log base 5 of 1 over, and what am I plugging in for x? This time negative 6 minus 1 over blank plus 1, and that is another negative 6. So that gives me log base 5 of negative 1/6 minus negative 6 plus 1 is negative 5, so I'm going to call that negative 1 over 5. Just like I moved that negative to the top to be negative 1/6, this right here is 1 over negative 5, so negative 1/5. I add the opposite, common denominator, work it out, and I still end up with 1 over 30. Okay, and so what you were trying to do there is check to see if it gave you a positive or a negative, and it did in fact give me a positive. So it did work out. All right, so check, and so both of these are what would work, 5 and negative 6. Okay, next one I have is 19. And 19 reads log base 7 of x minus 1/2 log base 7 of 4 equals 1/2 log base 7 of 2x minus 3. Okay, I'm going to bring my coefficients up as exponents first. Log base 7 of x minus log base 7 of 4 to the 1/2 equals log base 7 of 2x minus 3 raised to the 1/2. Now, I left the negative there and brought up only the 1/2. You could bring up the negative and change that to a plus. I'm not doing it that way. Okay, log base 7 of x over 2. X goes to the top because of the minus, it becomes a fraction. 4 to the 1/2 is 2 equals log base 7 of the square root of 2x minus 3. One log on each side, so I can drop them because they both have the same base. So I have x over 2 equals the square root of 2x minus 3. And you undo a square root by squaring both sides because squares and square roots are inverse operations. They undo each other. X squared over 4 equals 2x minus 3. And we multiply both sides by 4. Leaving me with x squared minus, x squared equals 8x minus 12. X squared equals 8x minus 12. X squared minus 8x plus 12 equals 0. X minus 6, x minus 2, x equals 6. 2, don't just assume because they're positive they work. Like right here, it's going to work here. Log of 6, log of 2 is going to work because they're both positive. But we have to check everywhere there's an x. If it doesn't work for one, the whole thing wouldn't work at all. Okay, so 2 times 6 is 12, minus 3 is positive. 2 times 2 is 4, minus 3 is positive. Check, check, they both work. 6 and 2 are my solutions. All right, and lastly I have 23. ln of e over the cube root of 5 equals 3 minus ln of x. Okay, I'm going to do it the way I did in notes. Again, you can change 3 to 3 ln of e. I'm not going to do it that way, but you can. I'm going to move the ln x over ln of e over the cube root of 5 plus ln of x equals 3. I'm going to condense that to a single log. ln of e over the cube root of 5 times x over 1. You don't have to put x over 1. I'm just writing it that way to show that it's a fraction times a fraction equals 3. ln of ex over the cube root of 5 equals 3. All right, there's only a log on one side, so I cannot drop the log, but I am going to wrap around. The base here is e that I cannot see, and I have e raised to the third power equals all of that. Okay, so that gives me e raised to the third power equals ex over the cube root of 5. All right, and I want to solve for x, so I'm going to multiply both sides by the cube root of 5. Cross out there. That gives me, I'm going to move it over, that gives me ex equals e cubed times the cube root of 5. Ex equals the cube root, I'm going to rewrite that. Ex equals e to the third times the cube root of 5. And then I'm going to divide both sides by e to get x by itself. X equals, like bases, so I subtract the exponent, so it's e squared times the cube root of 5. E squared is positive, the cube root of 5 is positive, so this is a positive number. It's going to work there. You would have to plug it in your calculator to see what decimal it comes out to be to plug it in there. I will tell you right now it does work, but you should still test it. And I'm pointing to the wrong piece. I should be pointing here, sorry. So let's test it again. The only place there is an x is right here, so we don't have to worry about plugging it in the calculator, because this is positive. E squared is positive, the cube root of 5 is positive, two positives being multiplied is a positive, so you plug it in right there. Ln of a positive is going to work. All right, that is it for this section of homework questions.